All right, guys, we are back for division. So yesterday we did our addition, subtraction, multiplication. Now we're down here for our four division problems. Now, before I start, I want to kind of explain what's up. For division, we're not allowed to have a radical in the denominator, meaning the bottom. So this little bottom piece right here, we're not allowed to have it. So what it's called is rationalizing the denominator. Now, I don't care if you know that saying or not, but what we do is we get rid of this radical. And how to get rid of it is we multiply both the top and the bottom by that radical. So I'm going to multiply the 6 by the radical 5, and I'm going to multiply the radical 5 by radical 5. Okay? And you'll see, it's going to go away. So if somebody is outside and doesn't have a radical and somebody is, you just rewrite it. This is just 6 radical 5. You can't multiply these two together to get the 30 because this one's not under the square root, okay? So you just kind of rewrite it. See how both of these are under the square root? Yeah, you're allowed to multiply. 5 times 5 is 25. Now, the cool thing about multiplying by the same thing in the bottom is the bottom's always going to be a perfect square. We all know that 25 is a perfect square. The square root of 25, it's just 5, okay? And we still have the 6 radical 5 on the top. Boom, done. Okay, see, not that crazy. It's just a little different. All right, let's try again, but this one's going to be a bigger number. So we're going to have to do a little something because over here, 5 is prime, okay? So that's why we didn't really have to do that much. All we had to do was get rid of the radical. 12 is not prime, so we're going to have to do something, but let's not think about it right now. Let's just rationalize that denominator and get rid of it. So the radical 12 is on the bottom, so I'm going to multiply the top by radical 12 and this bottom by radical 12, okay? That's the first thing I do. So 4 times radical 12, remember, is just 4 radical 12 because you can't multiply things that don't look alike. Now, radical 12 and radical 12, they do look alike, which is radical 144. Now, that is always going to be a perfect square. I promise you guys, perfect square is going to happen on the bottom every time. So if you don't know this, you can put it right in your calculator. So you'll push the square root, 144. 12. And let me give you guys a little hint. It's always what the number is on the bottom. So here we are. Now, here is the difference between the two. 5 is prime, so I didn't have to do anything. 12 is not, so I have to do a little tree. So let's do a little tree on 12. So I've got 4 times 3, which is 12. 3 is prime, so he's done. 2 and 2 for my 4. Circle up your partners. Underline your lonely. Now, just like that one that we did yesterday, when I try to take this 2 out, there's already a 4 there. So what do you do with the outside guy in the new set of partners? Yes, we always multiply. So 4 times 2 is 8, and we have our lonely, which is the 3, all over 12. Now, if you guys got here, I'd be so excited. Like, I really would be happy. But here's the thing. This 8 and 12 can be reduced. So you want to look at your two whole numbers. Don't look at that radical. You don't care about him right now. Look at your two whole numbers and see if you can reduce them. Well, 4 can go into both of these. Okay, so 4 into 8 is 2. 4 into 12 is 3. And you still have that radical 3 chilling out. So all I did is reduce that 8 and 12. That's all I did. Now, let's say you wanted to use your calculator on that. You know you have a button for that, right? 8, and then you would hit this ABC, 12. And it will tell you what it reduces to. Look, 2/3. All right, so what do you notice about these two that are different than these two? How many radicals does these guys have? Yeah, 2. So what you're allowed to do when you have 2 radicals is you can simplify first, okay? And by simplifying, I mean see if you can break these down to something smaller. So let's try our calculator. Just like I just told you, 27 and then ABC, 45. Oh, look, see how it breaks down to 3/5? So you're allowed to break them down so you can work with smaller numbers, okay, which we want to do. Now, once we break it down, we do the same type of thing that we did here, okay? Who's on the bottom? Radical 5. So I'm going to multiply the top by radical 5 and the bottom by radical 5. Okay, so you see how these are both in radicals? That means I'm going to multiply them. So 3 times 5 is 15. 5 times 5 is 25. And remember, that bottom is always going to be a perfect square. So what's the square root of 25? Yeah, 5. Still have my radical 15 on the top. Now, radical 15 is not prime, but look, if I try to find some partners, I get 3 and 5. Is there any partners for him? No. That means he is all the way simplified. Even though he's not a prime number, you can't reduce him anymore. Okay? All right, so 2 radicals. So I'm going to simplify it first. Let me put this over here. So I've got 10, and then remember I'm going to hit the ABC. 18. So 5 over 9. So I've got square root of 5 over square root of 9. All right, before you start doing your thing, you guys, you have to notice perfect squares. Is there a perfect square in this little situation? Yes, 9 is perfect. So what is the square root of 9? 3. Okay, then we still have that radical 5 on the top. So see how now we don't have a radical in the denominator, so we don't have to do anything. We done. And 5 is prime, so I know I don't have to do a tree. All right, try out your division. Ask questions if you need.